Hi there, my name's Sam Smallwood, I work for AMD. I'm here on the AMD FirePro stand at IBC 2014 and I'm here to demonstrate the advantages of the latest implementations of RealVNC, the software virtualization platform. So here we can see Autodesk's Maya 2015 running the Bullet physics engine. Now these two demonstrations are essentially exactly the same. One looks a little bit nicer than the other, but this one is running the same amount of objects and the same specifications as this one just down here. All of the rendering and the calculations are being done on the GPU of this system, which is the W9100 based workstation which is under the bench here. Now this one is obviously running natively and you can see it's looking very smooth, looking very good. This one here is not actually running on this laptop. This is running on another workstation we have behind the scenes which can't be seen here. All we're getting is the display output from that workstation. And as you can see, it's again running a 9100, so again a very high-end card. And what we have is again very smooth outputs from it. So we can see that what the laptop wouldn't be able to do is actually being done by the workstation behind the scenes. Now, this is being done using RealVNC. So we are remotely controlling that workstation from the laptop just here, but not actually doing any processing on the machine. Now, typically, RealVNC would be considered to be a software solution to virtualization. So there are hardware solutions out there as well, for example, PC over IP, where you have a hardware encoder and a card at the one end inside the workstation and a hardware receiver at the other at the client end of the system. Now, those are typically a more expensive implementation. RealVNC, being done in software, is a lot cheaper. However, that comes with its own caveats. Typically, software implementations are slower and a little bit laggy when used under these sorts of environments. So it's great for doing a rolling demo like this where the display data is basically coming out. But if I were to try and change things, that would typically introduce a little bit of lag. Now I'm going to load another demonstration on here which can show what we've done to alleviate this lag. So let's load up Particle DB there. So this demonstration is rendering approximately 50,000 particles in a random transition sequence. So as we can see, again the performance is extremely good. If I go to change the viewpoint now, typically on a software implementation you'd see quite a bit of lag, so several frames behind the actual mouse movements, whereas in this case I can change the viewpoint pretty much in real time because of the way that this has been done. So again, this is software virtualization, should be slower than it is. The way this is working is that all of the encoding and encryption at both ends is being done in fact on the AMD GPU. There is an API called RapidFire which is being used to offload that rendering and that encoding and decryption from the software solution which will be run on the CPU onto the GPUs. Now that increase in performance has a corollary of a reduction in the amount of lag that takes place, and therefore we can see that it actually results in a much better solution here from a software virtualized environment. So that's the way the latest release of VNC works.